This conference will now be recorded.
And let's give her another minute or two as people are starting to join in, and we'll get going in 1 or 2 minutes. Appreciate your time. All right, so hopefully everyone can hear us okay, and we have both video as well as the presentation we'll be going through here. Feel free at any time to put on your video if you would like, or you can turn it off. That's fine. And we'll get going in about another minute or two. And appreciate everyone's jumping on here for our webcast for the DC electronic load presentation from Vitrek. If you thought this was your family virtual reality happy hour, it's not, but feel free to turn it into a happy hour if you like. And we'll get going in 1 more minute. Okay. So we're just a couple minutes after 2, so let's get going. Welcome to the Vitrek virtual learning lunch for our new product, the electronic DC load. What we'll do is we'll kind of run through Vitrek in general, a couple other products that will show you how we have the expertise to go ahead and introduce the load. Really appreciate everyone joining this call. My name is Don Milstein. I'm president of Vitrek. We'll also have Chad Clark will also be presenting today. He's vice president of sales for the company. And we're excited for you to take some time out of this crazy time with the COVID-19, everyone working from home. Really appreciate you setting some time to get acquainted with what our DC loads and in particular from Vitrek and what we have to offer. It's been a strange time out there in the marketplace, but this is one of those ideal, opportunities to get educated. I know when everyone signed up, you were given the opportunity to get, hopefully a lunch on us from Grubhub, Uber Eats, DoorDash. If you've had any issues, you should have received a gift certificate or will shortly. If you've had any issues in getting that, just let us know after the conference and we'll make sure that gets out to you. But just kind of a way to say thank you for taking the time to get acquainted with us. You can see on the video, I'm wearing a blue shirt. I'll wave. Chad Clark. Go ahead, Chad, just put up a little wave there so you know who you are. So I'll start out and then we'll turn it over to the brains of the operation. And Chad, he's got, a lot of experience, over 10 years with Vitrek, and will do a great job in educating on the load itself. A few quick housekeeping issues. What we'll do is please put yourself on mute. This way we don't hear, the dog barking and the kid coming up asking for some ice cream or something like that. We're all dealing with a new way to work from home, but we'll do that, and then we'll have breaks throughout this session for questions. At any time, you can click on the button for the chat, and you just write in your question. We'll be monitoring that, and as we come to these different breaks, we will have those chat questions that we can answer. And then we'll also set up the microphones. And all you have to do is hit the microphone button. You'll be unmuted, and then you can ask your questions. So we want to keep it going that way, and we'll have these special breakpoints for questions. And feel free, right? The key here is to ask questions to make sure you walk away with some good information about what we're talking about. And with that, I'm going to go ahead and start off. Give you a quick overview on Vitrek. The company's been around over 30 years. We're headquartered in San Diego, California. And truly our focus is what's called the high voltage test and measurement, right? That's everything from accuracy tests, monitoring tests, high voltage safety tests, a lot of different products for that test environment, both for the excuse me, the engineering labs as well as production floors and at the laboratories themselves. Today, we've served well over 30, 40 countries with sales representation in all those countries. We're truly a global company. And our product lines kind of vary. We'll go through each one quickly, but HIPOT testers for electrical safety testing. We do a lot in the cable industry. Power analyzers to look at the energy consumption of different products. We'll talk about our high voltage meter and our new product, the DC load. One thing to note is that our facility in San Diego is accredited for calibration to ISO 17025. And that's good to note that not only when the product is shipped to you, it can be accredited and goes through that test, but over the years, you can send it back to us for calibration. That's for all of our products. And that just shows that high level of standard that we can maintain. And everything, because we're in San Diego, that's our only manufacturing facility. We're American made and do the calibration right there. So we're excited about that. Kind of the industries we serve, really across the map, right? Whether you look at the semiconductors or electric lighting, you go over to the Air Force and defense and avionics. It's really where we're focused, right? It's really business to business. And one thing I'm proud to say is that when this COVID-19 epidemic came about, we were right away, we had to abide by the shutdown in California, and we have as many people working remotely as possible, but we wanted to keep production operating. And in particular, we had a lot of requests from our medical customers and defense customers and aerospace customers saying, hey, we're in critical infrastructures. We look to you as a valued supplier. We want you to be there. And I'm proud to say that our team really stepped up. We're manufacturing, our people are in the office, taking all the precautions to be safe, and really being able to support this industry and keeping our social distance and all that, but able to serve our customers throughout the world. So I really wanted to highlight that from our own personal perspective. When you look at our customers, it's kind of across the board. Consumer products, right? We're in, with refrigerators with Sub-Zero, GE products, computers with Apple. On the commercial industrial side, you're seeing a lot of the big names in the electrical industry, as well as the medical field and lighting. On the sustainability side, we do a lot there, right? With electric vehicles, solar panels, as well as LED lights. So that's a big growth market. And then the last area is really the actual calibration labs around the country, as well as labs in different parts of the world for their actual testing for products, as well as the military side. So kind of diverse market as far as customer base. I'll go ahead to the next slide here. So from a HIPOT electrical safety test, it's one of our main products that we're well known for. We have two products, we call it the V7X and the 95X. And these products are really used when you have a product coming down a production line, like a refrigerator or a toaster oven or a computer power supply, and you want to test it for leakage, right? That it's not going to shock anybody. And you're trying to be in compliance with the different standards for UL and others throughout the world. This product has a full range, everything from 30 kV AC up to 15 kV DC. And the key is the accuracy and speed that it can test. It's both a touchscreen, which makes it easy to use from the user standpoint, as well as automated tests. And that's key, is being able to automate the test sequence that goes on there. The second product is our harmonic analyzer, power analyzer. This is key when you're looking to see the energy consumption of products, both in the laboratory setting when you're building new products. You want to test how much energy is being used, what the volts, amp bars, power factor, harmonics, making sure you understand that. And you have all the data that will accumulate, and we'll be able to graph it in a histograph or some kind of vector diagram. We can do a lot of standby power tests, make sure it's not consuming too much. Really solid tool for both the laboratory as well as on a production floor, and even integrated into some of the products themselves. Even though this product was extremely accurate, as you can see in some of the numbers there, we recently came out with a new one in the fourth quarter of 2019 called the PA 920. And this just purely kicks butt out there in the marketplace. It's really the top of the line, not only for us, but for the industry from an accuracy standpoint at 0.024% accuracy. Really the full range that people would be monitoring, and it's ideal from the data history to scope mode, waveform capture. So really a strong product, especially at those elevated levels of analysis like you're seeing with electric vehicles, aviation, and solar. We're excited about this product, and kind of gives you the feel of how we're into that level of technology. The other area is high voltage meter, very key for tests that want to see how much energy is being used at the high voltage level, really in the calibration side, right? And this product can go anywhere from 10 kV directly hooked up, or you take those smart probes that look kind of Frankenstein looking in the bottom left right hand corner there, and you can go anywhere from 35 kV all the way up to 150 kV with those smart probes. High accuracy, without a doubt, and also records all the information you need and helps people get into that next level of calibration and certification. About a year ago, we acquired a company called Zytron Technology, and it really expanded our line of not only power analyzers, but temperature calibration equipment, ballast test equipment, as well as LED lighting. So it truly gives us a full portfolio of products to look at. So with that, I want to kind of give everybody a chance. We'll open up the mics if anybody's got a question or if there's been any questions on the chat. We'll take a minute here before we introduce Chad. So from the chat, there's a question: does your ISO 17025 include harmonics on your power meters? I believe so. Chad, is there anything different there from that question?
Yeah, so I tried to answer that. I'm not sure that there is national traceability for harmonics. I went ahead and sent the scope over, and I can get back to him with a more detailed response, but we're not directly accredited for harmonics. I don't know that there's a national traceable standard for it, but I'll do a little more research and get back to you.
Perfect. All right. All right, so with that, I'm going to turn the discussion over to Chad. He's going to go ahead and present. Like I said, Chad's been with the company over 10 years, has all the information, has seen lots of applications throughout those years, and is going to talk about our latest product, our DC load, which we call the DLXX series. So we have lots of different versions of it, about 6 product lines. And with that, introduce Chad Clark, our Vice President of Sales and Marketing. Go ahead,
all right,
Chad,
guys. Hope everyone. All right. Thanks for tuning in. I hope everyone can hear me all right. So yes, at the very end of 2019, we released this new load. It's a brand new market for us. It's not really foreign. A lot of our customers are already using these products, but it is a new product for Vitrek. It was designed in San Diego by Vitrek, by our chief engineer, and supported by the rest of our engineering department. It is the unit uses a couple new concepts in the way that we operate, and we leveraged some of our touchscreen GUI that we used before in other products and our DSP technology to create what we think is a really good product, and we want to introduce it to you guys. I don't know how familiar you guys are with DC loads, but we'll kind of start at the beginning. So, you typically, to test anything that produces DC power, someone might have a resistor. That's great. You can make a resistor that's going to work for the voltage and handle the current that you're looking to test. But you're always going to have to be changing that. I know some of you guys are in your labs. You're going to have loads that you've built up. We have them, especially high voltage loads that we built up. But you have to reconfigure them every time. It's very inconvenient. So this is why the DC programmable load was invented, years ago. All it really does is it's a power sink. It's I don't want to say infinitely variable resistor, but a highly variable, quickly changed resistor is basically all it is. our particular product can operate, down to near open circuit to a closed circuit up to 500 volts. And we can do that with, just like everyone else, constant voltage, constant current, constant power modes, or constant resistance modes, but we're not limiting you to one of those. And we get into that a little bit later on how it works. So let's see what happens. So we've kind of broken the load down into 6 different models. All of the models are going to support, most of the industries, whether it's DC to DC converters, power supplies, battery testing. You're really all doing the same thing. The difference is what power level do you need and what voltage ratings are you looking at. The way that we've broken it down is there's basically, you get 2 voltage options. You can either be 0 to 150 volts or up to 500 volts. And as you would expect, if you choose the 500 volt version, you're going to have a little bit worse performance at the lower voltages than you would with the 150 volt version. But obviously, with the 500 volt version, you can test above 150 volts. We're seeing more DC applications that are higher in voltage as people are concerned about efficiency. Higher voltage, lower current, less copper. So it's kind of a win-win. When it comes to power ratings, the unit's really kind of modular, and you can see it in the photo. It's split into basically 2 halves. We can do 250 watts RMS kind of per side. So it's the same chassis. You can get it with a 250 watt, which would kind of be a half build, or a 500 watt version where both sides are populated with heat sinks and fans. And then we also have what we kind of call a quarter build, which is a 125 watt version. And you can get that in either voltage rating. The unit's designed to suck air in from the sides and the bottom. So it can actually mount too wide on a rack. I think we'll get into that later. And that is it. It's a 5-inch touch screen. As you guys can see there, there are no buttons on the front panel with the exception of the encoder. And what's unique about it to other loads is that we have high transient capabilities, and we'll get into that later in slides, but we're able to measure, or I should say load kilowatts for short periods of time. And then we have a unique scope mode. A lot of other loads lack a detailed graphical interface. And reading the manual of some of the competition, they will literally say, if you want to do this, hook up a scope. And in most cases, you don't have to with our load. So moving on here, got some pictures here of the front and rear panel and sides. I'm not sure if we get into the interfaces. We do get into the interfaces later, so I'm not going to go into too much detail on it. But so it's integrated meter for obviously voltage, current, power, resistance, conductance, depending on how you want to look at resistance. It's got a built-in oscilloscope and built-in logging. You can use a USB thumb drive on the front panel, insert it, download. You can pull screenshots off of it. You can use CSV files. Pretty much more data than most people really want. You can pull that out of the unit and manipulate it however you'd like at that point. Let me see here. So the application side of it is it's really broad. So the fact that it is, all it does is sync power continuously. We're not really limited to much. Power supplies are obviously the big one that comes to mind. It's used in conjunction with our power analyzer a lot for inverters, inverters and converters, DC to DC converters. Anytime that you're changing the voltage or going from AC to DC, there's going to be loss. So obviously, people need to know what that loss is and see how efficient your converter is going to be across different loads, different voltages, things like that. Obviously, it can be used with photovoltaics. It can be hooked up directly to a PV panel. Batteries and fuel cells, either at the pack level or at the individual cell level, just depending where you want to be. We have the power to handle packs. We have the accuracy and resolution to look at something on a single cell level. Looks like someone's asking something about sampling frequency. And let me see if I can pull it up. Yes, the meeting is being recorded. The sampling frequency of the scope, it's kind of complicated and it's going to depend on what modes we're in, but I can get that answer to you. All right, so battery testing. Obviously, everyone has a specification on a battery, and it's going to be typically a watt-hour, ampere-hour capacity. As you guys know, depending on how you discharge that battery, you're going to get different amp-hour or watt-hour capacities. You can use our load to set up a arbitrary loading cycle that might mimic. We use this example all the time. You know, your battery-powered drill. It's typically not used continuously. It's used at high levels of power for, periodically. Maybe every 20 seconds, you're going to use it for 2 seconds. That profile is going to yield you a different battery capacity than high current continuously or low current continuously. We're able to calculate that regardless of how it works or the profile that we're using. Typically, if you're using this battery capacity mode, you're going to set a time limit. If you were doing a capacity test, let's say you wanted to verify that, within an hour, you're going to get a certain amount. You can set a hard time limit. You can also set a voltage cutoff limit. Most battery, at least with all the lithiums they do in the battery management system, have a cutoff. And, you'd want to set our test limit right at that or slightly above it. So it doesn't shut off first. And we give you all the data.
Chad, one real quick note I forgot to mention. We will be sending everyone that attends this session a copy of the slide deck. So if you don't catch all the notes you want, you will get a copy of this. So,
all right. And it looks like Brian jumped in and answered that question. We are at 400,000 samples per second. So thank you for that, Brian. This is kind of an interesting graph. I think that Brian actually put together. So we were talking earlier about our transient capabilities and our capability of loading beyond the 125, 250 watt or 500 watt version. This is something that I believe is unique to us. It may not be, but I hope to be proved wrong if it's not. So I know it's a little bit hard to see the different colors here, but if you look at this is on a logarithmic scale. If you look at the purple line in the center, it's kind of a little volcano peak. I'll use my hands here. Yeah, right there. That is going to be what you typically are going to see out of a DC load. You have a voltage cutoff that approaches. I can't actually see the resolution there. Let me see if I can up right here. So you're at somewhere over a volt, and then obviously it's going to top it at about 60 amps or so. What we can do is have voltage accuracy and the ability down to really deep into the mud, down into the microvolt region, and then everything to the right of that purple line and blue line and above it is our ability to load in excess of our specification. So this is of our RMS specification. This is a 250 watt load where for less than 100 microseconds, we can load at 7.2 kilowatts. It's pretty impressive. In other situations, someone might have to purchase a 7 kilowatt load if they want to do, transient loading up to those kind of levels. And with us, you do not have to do that. You can see the different lines correspond to different amounts of time, and it ends up being ultimately kind of a heat average. But if you looked at it graphically, you can see that we represent a much wider area of ranges where we can load voltage and current combinations. It's, 5 times the surface area, if you want to look at it that way, that we are able to measure at or load at, I should say. All right, so now we're kind of getting into the front panel shot and the screen. The only thing that's really unique here is that a lot of the competition uses either soft keys or 20 or 30 different keys to program this. If you guys have used our products before, I think you're familiar with the fact that you can typically touch something, it'll open up as an editable field, make your changes, and then go back and it'll save it. And that's kind of the same way that this interface works. So we got a 5-inch touch screen on this, fairly high resolution. I believe it's the same resolution that we use in our PA900 series, which is a bigger screen. This one's smaller. The encoder knob there, the adjustment dial, is going to let you, change through. If you wanted to manually sit there and change your current or change your resistance, you could scroll through and do that. Also during setup, it's going to let you go through, and just like anyone else. For convenience, we do have bananas on the front panel. Obviously, you're not going to get full specs out of the bananas. I think we use them up to 30 amps or so. 500 volts peak, 30 amps is what it says on the front panel, which is great. It's convenient. If you want full specs, we have blades sticking out the rear. We do have an indicator light for when we're loading and unloading, or unloaded, I should say. You'll also see that load being active or inactive on the panel. There's also a, on the graphics screen, I should say, there's another window that lights up. Power indicator, and then that USB host port, which is very convenient. Going on to the back, we are LXI compliant. This is kind of this is the first Vitrek product actually that's actually gone through the effort of complying with all the LXI standards. We believe that the future products are going to do that. We like it. We're getting good customer feedback about that. So rear panel, like I said, there's the blade terminals with a cover to go over them. That's where you're going to get full specs, best performance, higher current ratings. You can just simply bolt through those with a ring lug and a bolt. External voltage sense, if you're concerned about voltage drop through your test leads and you're trying to make an accurate measurement, you may want to use those. Once again, Ethernet is standard interface. USB is also standard, and then we do have the digital I/O port, and this uses a DC brick, which is convenient, especially for a lot of our international customers and things like that. There's no issues opening the unit up, switching from 120 to 240 volt. And obviously, and if your power supply does go out, you can just buy another one and plug it in. Everyone seems to be happy with that. A lot of our products are kind of going in that direction. So there we go. All right, so this is some of our features here. So like our power analyzers, we try to be rangeless whenever possible, or have less ranges. This allows us to have a more linear accuracy. You won't see that sawtooth effect that you'll see with a lot of other people's products, where as you switch ranges, not only can you lose measurement during that range switch, you also can have drastic changes in accuracy. We specify a 0.05% loading accuracy, which is, more realistically, it's more accurate than most people are going to need for most applications. But we did the same thing with some of our power analyzers and our HIPOT testers, and we found that offering a higher accuracy product got us into applications that we wouldn't even been in before. There's probably some people out there that are not looking at electronic loads right now because configurable through the front panel. You can select exactly your load profiles. All right, so this is something that's kind of interesting. Typically with most loads, you're going to have to operate in a constant current, constant voltage, constant power. What we can do is basically have all of those limits in place at the same time, and it allows you to operate within a field. It's convenient because sometimes if you fire up a power supply, for example, you're going to want to start in constant current, constant current, and then maybe you want to switch over to a constant voltage and hold that thing at a certain voltage. But if you try to power it up at constant voltage, it's not going to work well because it starts obviously at 0 volts. So it's kind of convenient. Arbitrary mode. This is what we were talking about earlier, where you want to be able to have a load that simulates real life use of the product that the power supply was designed to use. So whether that's going to be pulsing or periods of high use followed by no use, standby, sleep mode, things like that. We can emulate all of that, and we can do it quickly and accurately. So on the next slide, we get into some more of the features. So battery test mode, we did cover that earlier a little bit. One thing that we really like is, and this is a screenshot of it, is it is the graphical web browser. So you can actually enter the IP address of the product, and you can use it just like you were at the front panel. Obviously, there's a little bit more delay than if you were using it directly, but you can, turn the knob, touch the buttons as you normally would, and set it up and use it remotely without having to be a programmer or anything like that. If you've used it from the front panel, you could log into this thing from the office and make changes. And that could be anywhere in the world. So 0 volts up to 84 amps sustained is our top spec on current. Obviously, that'd be from the blades. Might be a little unique. I don't know if there's a lot of people that are still manufacturing loads in the United States. This is all in Poway, which is about 5 miles out of the summits of San Diego. Like we said, we're LXI certified. That's all over the Ethernet port, but USB is available, and it's very convenient. Although it does offer a few downsides, it's certainly convenient. Does anyone else have any questions about the load or anything else? And also, if you guys do have questions, you can shoot an email to sales@vitrek.com at your convenience, and we can get those questions answered or send you back supporting documents, whether you want a manual or data sheet or have a question. All right, so now we're going to look at some screens. And quite a few screenshots here to look at. So basically in this one here, it's kind of a standard setup. You're looking at voltage and current, power and the resistance. But the cool thing is on the right, we're showing our scope mode right there. Everything auto scales, and you can record that. You can screenshot it. We're switching from A to B, different current levels, and that's all shown on the scope. You can zoom in, you can look at the history. There's a lot of flexibility there. It's similar to the power analyzer from an interface standpoint when you're looking at using the scope feature. A lot of the similar scaling abilities are there. See, on the next screen, we have a let's see, we got Y. This is also valuable. A lot of people are taking these screenshots and putting them directly into the reports. they wanted to test a power supply and see the response of it, you know, here's proof right here, and that gets exported, goes into the report, and now they have some visual representation of the performance of that product. And we have our history mode here, so you can go back and you can zoom in and you can look at events that happened in the past. You just set that thing up to run, and once again, it will auto scale. And you lose resolution over time, but I'd have to double check the manual, but you can run the history screen for a very, very long period of time and still go back and look at events. So here's the settings screen. Once again, all of this stuff is editable. So if anything that looks like a button, you can pretty much touch, open up, and edit that. This is going to be the, you know, it's kind of standard looking right here. Setting up your load, configuring it. On the right side, you're going to have all the different modes. It's pretty simple. You touch the button, you configure basic, table, arbitrary, whether you want to do a sweep, switching between A and B, minimum or maximum conductance. It's all available. And hopefully you guys can get your hands on one, take advantage of the demo program, and actually see how this thing works. So there's some options when you are data logging. Not everyone wants you know, the exact same amount of data. So there are some ways to get the end result a little bit more tailored for what you plan on doing with it. And then you can look at full system information, you know, total memory used available on the SD card. Everything's there, model number, serial number, whatever you may need, including the IP address. It's a nice, easy way to go look at it. If you do want to go use the web interface, here's your IP, and you're good to go. The next one's going to be the system configure options. Once again, it's fairly simple. You get to this screen, you select what you want, it's going to pop up what's there. We do have a self-test that's very thorough. You know, some people might do this on a daily basis just to make sure everything's working properly. Let's see what else we have here. The next screen we're looking at. So this is kind of where we got into the fact that we have all of these different models, and it is 6 models. Somewhat intuitive. The first level represents the voltage or the power levels, and the voltages are represented in the model. We do specify there the maximum instantaneous power. And another thing, we do not hide behind our prices. You can go to Vitrek.com, you can look up the actual price of, I believe, just about every single one of our products. There is no contact us or anything like that. We're kind of proud that we're able to make these products in the US and still be competitive price-wise with some of the overseas products. Price performance, it's going to be very hard to beat this product. I highly recommend it. And that's about all we have prepared right now. Obviously, there's a lot of technical information here that we didn't get into today. This is more kind of just an overview. And I encourage you guys to ask specific questions if you want to get into you know, specifics and details. And those typically will be about your unique application. So please shoot us an email and let us know what we can do.
Yeah, Chad, thank you very much for that excellent presentation overview. You know, there is a question that came over about lead times. This is on the shelf, so our lead times, you know, basically within a week, we can get these out. A larger project might take a little bit longer, but not much. So we're ready for this product line. There's no question about it. We've already shipped them internationally already and throughout the US, so we're ready to go. Anybody else have some
most
questions?
of our products are in stock and calibrated the orders. We're like, 2 to 3 days can be typical. Sometimes it can be as long as a week. If you guys need something sooner, let us know and we can work with you. Lead time should never be a reason to, to not order something. In most cases.
All right, well, if there's no other questions, just want to again thank you from everyone here at Vitrek for your time during this little epidemic we're all going through, and hopefully you and your family and your company's families are all safe, just like we are here at Vitrek. And look, your contact information is there for Chad directly or to sales@vitrek.com for any follow-up on this or any of the other products. And our goal is to do some of these more series on this, both from an application and product. So look for your emails, and if you did run into any issues with your gift certificate, just feel free to email, sales@vitrek.com or Chad, and we'll get that taken care of.
We can do that.
And with that, I thank you very much, and everyone enjoy the rest of your day. Thank you very much.
Thanks, guys. Bye-bye.
Thank you. Bye-bye.
All right.